Hello and welcome once again to our virtual meeting, ladies and gentlemen. Today we are going to be going over 28-1. We're going to be talking about mean and outliers. And so with that in mind, ladies and gentlemen, as you know by now, you can take a look at the notes on OneNote or simply follow along by pausing as we go along and copying the notes so that you're not falling behind. So when we're talking about the mean, ladies and gentlemen, we are simply talking about the average. So anytime you hear the word average and we're talking about math, we're talking about what is known as the mean. All right, so that is quite simply what we're talking about here. And in order to calculate the mean of a data set, so you have a set of numbers, and in order to calculate the mean, all you need to do is add up all of the values that you're talking about. And then, so that's step number one, you add up all the values. And step number two, you divide that sum by the total number of numbers that you added. For example, let us suppose that you wanted to get the average for the number of absences that I had over a 9-week period. All right, so that means that during week, well, I would get the absences. So week 1, we had 4 absences, and this is just hypothetical. So week 1, we have 4 absences. Week 2, we had 6 absences. Week 3 would be 5. Week 4, 0. Week 5, 7. Week 6, 3. 7, 4. Week 8, 6 absences, and week 9, we had 5 absences. So notice how I have 9 values in this data set, 9 different values or 9 values representing those 9 weeks. Step number 1, we're going to add all those values. Okay, to get the average of all of these numbers, we're going to add them all up. So 4 plus 6 plus 5 plus 0 plus 7 plus 3 plus 4 plus 6 plus 5. And that gives me a total of 40. So that's step number 1. I got that sum of 40. Step number 2 now, ladies and gentlemen, I'm going to divide that sum of 40. I'm going to divide 40 by 9. 9 because there's 9 values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 40. Divided by 9, I added 9 numbers to get 40. That gives me 4.44. So that means, ladies and gentlemen, that the average number of absences per week during this 9-week period that I have right here represented was 4.4 absences, which of course, there can't be, during any given week, I can't have 4.4 absences. I can't have 0.6 of a person missing. Right? It doesn't work that way, but that just gives you a general idea of how many absences I would expect to have or I had in each one of those weeks. You can think of it as a balance point of what is representative of the data that you have there. What is a good representation of the data that you have there? A good way to represent this data, I would say, well, my average absences during that 9 weeks period was 4.4 absences. To give you a better idea of how exactly we're doing this, if you actually go to number 1 on OneNote, let's go to number 1. Notice how we're given a data set consisting of 23 values. These values represent the heights in inches for students on a soccer team. All right, height in inches. So this is 57 inches. So that's one student was 57, another one was 55, another one was 60, another one was 55, etc. So we have 23 different students here. Here are their heights, and here are their heights plotted on a dot plot. So those 23 values are plotted here in the dot plot. Now notice, ladies and gentlemen, if I were to ask you what was the average height of those students, what is the average height of these students? I'm essentially asking you around how tall are these students? I'm looking for one number that is a good representation of how tall these students are. And so you can think about it as what is the balance point? What is the balance point for all of these? And looking at this data set, notice that it's not necessarily symmetrical, but it does look something like this. All right, so we're asking, where is the balance point visually? What does it look like? And to me, it seems like the balance point would be somewhere between 57 and 58. So I'm going to assume that it's about 57. So for number 1, just go ahead and put 57. As a class, we're going to put 57 as what is the estimate? Notice that it asks, what is the estimate for the center of the distribution? All right, so I think it's about 57, maybe a little bit more than that, but 57 is what we're going to put as a class for number 1 on Schoology. That is the average height in inches for the students in this soccer team. So if they ask me, what is the average height, I would say around 57. Now let's actually calculate the mean. Let's actually calculate the average height by first adding up all of these values and then dividing by 23 because there's 23 different values. All right, so let's go ahead and add all these up. So 57 plus 55 plus 60 plus 55. I'm essentially adding all of these. So 53 plus 54 plus 54 plus 55 plus 55 plus 55 plus 56 plus 56 plus 56. All the way down to here, guys. So go ahead and actually add all of these values together. And having done that, you're going to find that when I add all of these together, I get a total of 1,320. 1,320. That is step 1 for finding the mean. We first add up all of the values in the data set and the distribution. Step number 2, we're going to take those values, 1,320, and I'm going to divide that by 23. By 23. And we only need 2 decimal places because we need to round to the nearest 1/10 of an inch. So if I go ahead and do this, and I'll do this with a calculator, feel free to do this with a calculator because it's a longer process. 1,320 divided into 23 gives me around 57, and I'll do it in a different color, 57.39, and it keeps going. 39130435, whatever. But remember, we're rounding to the nearest 10th of an inch, and this is in inches. So now I can actually round to the nearest 10th by looking at the hundredths. That's why we need 2 decimal places. So that's going to become 57.4. 57.4. That is the average, that is the mean height of those 23 values. I added them up and I divided by 23. So we're saying that the average height of a player in this soccer team is 57.4. Notice that 57.4 would be about right here. So slightly to the right of where we estimated. So did we have a good estimate? I would say so. I think we had a pretty good estimate. Notice how it is the balance point, the average is pretty symmetrical, right? It's pretty much right in the middle of this distribution. That is where the values would balance. And that's how we get the average. Now, the average does not always represent the most that we have here. For example, if we had a lot in 56 and we had a lot in 58 and the rest was symmetrical, the average would still be about 57. The average would still be about 57 because notice how we would still balance around the point 57, at least visually. So that is our mean, that is our average. All right, well, let's try something a little bit differently. Let's go over to number 4. And notice in number 4, we have a dot plot for the same distribution that we used last week for the time in minutes that it took for students to finish a test. Remember that we had that one student that finished like in 15 minutes? And that's right here. We had one finish in 23, and then the rest of the distribution is over here. Here we have 24 different students, so we have 24 times for those students. And notice the shape of this distribution. If I only consider this part over here, notice how it is fairly symmetrical. It's pretty much just like a triangle, right? If I were only accounting for these numbers over here, if I were to exclude the 23 and the 15, notice that the average, I would expect the average to be here around 35, right? I would expect this to be the average. However, I cannot ignore the whole distribution. This is part of the distribution as well, right? This part over here. Notice how these two values are skewing the distribution to the left, right? And so given that fact that I have these two values over here, I would actually expect the average to also be skewed to the left a little bit. I would expect it to be over here, somewhere between 30 and 35. So let's see, let's actually calculate for number 5. Let's go ahead and this is what we need for Schoology. Let's go ahead and calculate the mean. Let's go ahead and calculate the average to the nearest 10th. So again, we're going to add up all of these values. So 40 plus 30 plus 23 plus 35 plus 28 plus 29. So we're going to add up these 24 values, which gives us 803. And then we're going to divide that by 24 to see what our actual average is. So we do 803 divided by 24, and we get, that gives us 33.45. We only need 2 decimal places because we need to round to the nearest 10th. So that 4, because of the 5, would actually become 33.5. So that means, guys, that the actual average is about right here, just as we predicted. Notice how, because I have 2 points over here skewing this distribution to the left, it actually moves what the expected average to the left as well. That's what those 2 values do. In other words, if we only had these values from here to here, from what appears to be 27 to 41, if we only had those values right there, the average would clearly be about 35. That is the point of balance. That is our average. I would say the average time it took for students to finish the test is 35. But if I include all the whole class, including the 2 that finished relatively early, that skews the average closer to 30. It skews us to the left, just like the distribution is skewed to the left. So that's why my actual average is 33.5, which is the answer to number 5, 33.5. All right, so let's actually skip number 6 and number 7. Let's go down to number 8. That is actually one for Schoology as well. Should we take out these 2? Should we take out the 15 and the 23? Should they be removed from the data set? What do you guys think? I mean, ask yourself, are those actual people in the class? Did they actually finish at the time, or was that just a mistake? If it's true data, you can't just choose to take it out. You cannot just say, well, it doesn't look that pretty. I want it to look nice and neat, so I'm not even going to include those. Those kids don't exist. No, you cannot do that. That would be disingenuous. That would be a lack of honesty. You're not being true to the actual results of the distribution of what we have here. So no, ladies and gentlemen, you cannot just ignore those values. Okay, so that's why our average is here at 33.5. Now, what would happen? What would happen if we actually took these off? Let's just pretend that we took off the 23 and the 15. Well, if I took those off, clearly my distribution would be symmetrical. And so I would expect the average to be somewhere right in the middle, which seems to be about 35. That is going to be my prediction for number 9. It would move to the right. The average would move to the right. That would actually be the answer to number 9. And let's go ahead and actually try this out. So if we remove, we added all the values up and we got 803. And if we remove the 15 and then remove the 23, notice that now we have 22 values. This would actually give me 765. So that's like if I added 22 of the values, not including the 15 and the 23. So for number 10, let's go ahead and actually get the average with the remaining 22 values. So that would be 765 as opposed to 803, 765 divided into 22, because now we're only counting 22 of these values. So all the values except for this one and this one. So let's go ahead and try it out. 765 divided by 22. 765 divided into 22. And that gives me 34.77, which rounds to 34.8, 24 and 8 tenths. Notice, ladies and gentlemen, that is pretty close. That is pretty close to 35. So 34.8 is just right here, right next to 35. Notice how it's pretty much right there in the middle of that distribution. Notice how our hypothesis was correct. When we took off these 2 points, it levels out. It is no longer skewed to the left. Now it is just almost perfectly symmetrical. So our hypothesis was correct, ladies and gentlemen. So yeah, that's pretty much it for that problem. Notice how whenever we have outliers, so that's what I want you guys to get from that. Whenever we have outliers, which are values outside of the general pattern of the data, values that don't seem to fit together with the rest of the values, like right here, what we have with number 15 and 23, they skew the average of the whole data set. That's what they do. All right, ladies and gentlemen, hopefully this was a good introduction into average, which is the mean, and also into outliers. So now for number 22 and 23, you guys are going to answer these on your own for number 22 and number 23. All right, look at these 10 points. Are there any outliers? Is there any value or values that seem to be outside of the rest of the pattern of the data set? And then in number 23, actually calculate the mean. Go ahead and add up these 10 values and then divide by 10 because there's 10 values right there. All right, ladies and gentlemen, I hope you found this helpful. And with that in mind, I will see you next time.